Hello and welcome to another video lesson. In today's lesson, we are going to be using a linked list to store a to-do list. And I'm going to go ahead and read the documentation for the lab first. We're going to go through it. If you want, you can go through it along with me. So the program overview designates that we want to create a simple to-do list application that interacts with the user through a menu-driven interface. So that means that we're going to be outputting a 1 through 4 task list, and then the user is going to select from option 1, 2, 3, or 4 to tell us what they want to do. So the program allows the user to perform 4 actions: add a task, remove a task, display the task list in its completion, and exit the program. To manage the tasks, the program uses a singly linked list. Each task is going to be stored in its own node, where each node contains both the description of the task and a pointer to the next node in the task list. The program operates on the linked list, performing insertion, deletion, and traversal options. So the user requirements are that we need to, 1, prompt the user to make a numbered selection from the following operations: add a task, remove a task, display a task list, and exit the program. So to add a task, we want to prompt the user to enter a task description and then add that to the list. When we remove a task, we want to prompt the user to enter the description of the task they want to remove, and then search for the node within the linked list, and then delete that task node. And then we want to display the task list in its entirety. This is a simple traversal, and then output of the information portion of each node. And then exit the program using the word goodbye to verify that the program did indeed exit. We need to allow the user to interact with the linked list to manage the tasks. The program should keep running until the user chooses the exit option number 4. The program should be able to dynamically add and remove tasks by modifying the linked list as the user interacts with the menu. And then I have a sample output. You can take a look at this on your own. It just kind of shows me picking 1 for the first 3 iterations of the do while loop, and then adding various tasks: wash a car, do homework, cook dinner. And then I remove do homework from the list, and then I output the remaining items in the list: wash car, cook dinner. And then I exit the program by entering choice 4, and the program outputs the message goodbye with an exclamation point at the end, and the program terminates. So the requirements of this program are to, 1, allow for user interaction, so display the menu with the 4 options: add a task, remove a task, display all the tasks, exit the program, and prompt the user to select a valid option between 1 and 4 from the menu. The task management should be performed using the linked list. So we're going to store our task in nodes of the linked list, and each task node should have a description field that tells us what the task is that the user wants to store, and a pointer to the next node in the list. To add a task, we prompt the user to enter a description, create a new node, add it to the list at the end. Removing tasks, prompt the user to enter the task description they wish to remove, and then remember that the string needs to match exactly what is stored in the task description field of whatever node they wish to delete. We search for the node containing the exact matching description and remove that node from the linked list, while ensuring that the rest of the linked list remains intact. And we display all tasks for option number 3. We print all the tasks that are currently stored in the linked list and ensure that they are printed in the correct order that they were added, so not random. And finally, we want to exit the program. We want to be able to allow the user to exit the task list, to-do list program gracefully terminate the program after displaying a goodbye message with a little exclamation point so it seems friendlier. And then that's it. So to do this, remember in previous lessons, we used a struct to store, to create node objects and then designate variables for those objects like an information field and a pointer to the next node. This time we're going to use a class implementation to organize all of the information for our task node object, our to-do list object. We're going to obviously create the implementations for these, and then we're going to have a main file, main.cpp. So let's go ahead and get started. I am going to add a file, and we're going to start with the header file because we already know some of the things we want to do, and so those will be represented as member functions of our two classes that we're going to have. We're going to have a task node class and a to-do list class. So let's go ahead and start with that. This is going to be called to-do list.h. Okay, and we're going to start the class with if def to-do list underscore h and hashtag define to-do list underscore h. We're going to include some standard boilerplate items if we want to use strings, which I believe we do, and include IOStream and using namespace std. Okay, this looks good so far. We have a little squiggly error, so let's go ahead and complete the end if right now. Hashtag end if, so that we don't have the red squiggle and we don't forget to do this. We don't forget to complete if and def with end if. Okay, so the first thing we want to do is create our class for our task node. Okay, and we're going to have some public member variables, and we're going to have just public member variables. we want to be able to the public members are intended to define the interface of the class. So these are the functions or variables that we want to be accessible to the outside world. We want to be able to access these. So that's why we're going to make them public. I'm going to create a backspace on this actually. And we're going to create a string task description. And this is going to be the information field of the node. And then we're going to have a task node pointer to the next node. And I'm going to get rid of some of this stuff here, the space, because it's not cool. I always try to stress to you guys to write clean code, and that means like having like spacing, but more than that, it also means having consistent spacing. So if I'm going to, for example, I'm not going to leave a space after this, I need to do that for every subsequent class that I make, and just make sure that my spacing is consistent. That is important, at least to readability. We are also going to add task node string description. So 1 second, let me make sure I'm doing what I got to start doing. I just about forgot to include the class constructor. So in this case, we are going to use the overloaded constructor that designates the description field within the parameter setting. And then we should be able to move on to our next class, the to-do list class. So this spacing looks fine. I have some member variables here, and then I have a function. So that spacing looks good. I'm going to continue. Class to-do list. Okay, and let me go ahead and put the semicolon at the end before I forget. And we're going to have private member variables. So I'm going to do this and then I'm going to explain it. We're going to have a task node head. And this is going to be our pointer to the first task in the list. And it's private because as the list manager, the user of the to-do list class shouldn't directly be able to manipulate the nodes. So instead of that, the user should interact with the list via the public member functions. And by making the head private, we are going to ensure that the linked list is only accessible in ways that are controlled and foreseeable. So like for instance, we're going to add some functions to add a task, remove a task, display task functions, etc. And we want those to be accessed directly by the user. We do not want the nodes themselves to be directly accessed by the user. So that's going to be private. Now for public stuff, public member variables, public member functions, we're going to start with the constructor, which is what I almost forgot when we did task node. And that's kind of one of the, I guess that's kind of one of the drawbacks, I think, to using something larger like this. You have to think more broadly, and you have to, there's kind of a lot of like don't forget to dot your I, cross your T's kind of thing with classes. But the more we do them and the more we use them, especially when they're warranted, like in a situation like this, the better we get at doing them. So let's go ahead and start with our constructor. We're going to have an overloaded, no, we're just going to have a constructor. We don't need an overloaded one. Let's just do that. Let's just go ahead and do this as they come along. So do to-do list, constructor. We're going to also, in this case, need a destructor. And that's to free the memory at the end of the program. And to create a destructor, we use a tilde, and we use the name of the constructor. Okay. Sorry, I'm drinking a drink right now. So if you hear, I'm so sorry. Like, it's the ASMR you guys didn't ask for. I just want to apologize ahead of time. So we also want to add a task to the list, and to do this, we're going to use a void function, add task, and it's going to have const string ampersand, and I'll explain this in a moment. Task. Some of you may already know, some of you may not, and I just want to make sure we're on the same page. So just a moment. Okay. So we're going to use the address of operator in this case. The ampersand symbol is going to be used to indicate a reference in specifically in C++. We use this. So a reference is like, it's an alias or a nickname for another variable. So when you pass a reference to a function to directly access sorry, I'm getting mixed up. When you pass a reference to a function, you're gonna be allowing the function to directly access and potentially modify the original variable without needing to make a copy of it. And the reason why we're going to do this is because it's efficient. Because when we pass larger objects like strings by reference instead of by value, it avoids unnecessary copying, which could be costly, especially like if the user enters something large, because yeah, strings could be large. So copying them requires creating a new copy of the string, which is, it's not as efficient. And we did cover pass by reference, pass by value in the first week review. So go ahead and review that if you need to. And we also do it for mutability. So if the function is going to be, if the function were to like modify the string, in this case it doesn't, but I'm just saying it because here's another reason why we do this. Passing by reference is going to allow changes to affect the original variable. So this altogether means that you're passing a reference to a string, no copy of the string is made, and instead any modifications in the function would directly affect the original string passed to the function. But in this case, we're not modifying anything. We're just storing, we're going to be storing something. And then this, const. I don't think we really talked about this before. I'm not sure. The const keyword means that the variable is read-only within the scope of the function. So in other words, you cannot modify the value of the string that is passed to the function. And we use this to protect data because when you pass something as const, you're ensuring that the function won't accidentally modify the data. It's a safeguard. It makes the code more predictable, safer. It's more efficient in combination with the ampersand because it allows us to pass large objects like string by reference without worrying about the function modifying it. And it improves efficiency because no copy of the string is made, but also that the original data isn't changed. And I think that should do for explanation. So remember, we're saying that const that this is going to indicate that the task description will not be modified within the function, and that we're using the string ampersand, so the variable name and an ampersand indicates that task description is passed by reference, which means no copying of the string is created. So it's more efficient, especially if the string gets large, because it avoids copying the entire string data. Okay? All right, so let's keep going. And I'm glad we covered it here because we're going to do it again for the next function. Add. No, I think the next thing we should do is remove the task. Task by description. And it's going to be another void function, remove task. And it's going to take in the same argument. Okay, and we're going to put a little semicolon here. And then display all tasks, another void function, display tasks. Okay, this looks good. I think this is good enough. Okay, I'm going to save it. So I'm going to save our changes to it. And then we are going to start working on an implementation file. So let's go ahead and add another file here, to-do list.cpp. This will be the implementation file that will host the definitions of the terms that we have in the header file. So I'll go ahead and press enter here. And to start, you know what? I just realized something. I think I can make this bigger. Can I? Yeah, just 1 second. Okay, so I zoomed in a little bit off camera, so it should be a little easier to read. Apologies if, when I was creating the header file, if it was hard to see. I did include the copies of the files that I'm using in this code in the module, so you should have access to them, but I do apologize if it was hard to see. I know that it could be part of the draw of the video lessons is that you're able to follow along, so I apologize for that, but looks like the problem should be corrected. Let's go ahead and create our implementation file. We start by making sure that we can see our to-do list header file, so we include it in the implementation file. Don't forget to do this. I know that we introduced classes a couple weeks ago, and maybe you're not super familiar with them. Some of you are, but some of you might not be. And so this is good practice for us. So the first thing we want to do is create the to-do list constructor. then we will name the class, scope resolution operator, name of class again, empty parameter, and we're going to say that head is null pointer. And what this is going to do is it's going to initialize an empty list. Okay, this is good practice to have, right? Okay, let's continue. We are going to create the task node overloaded constructor. And this is going to be, again, the name of the class, scope resolution operator, name of the class. When we do constructors, this is how we do that. String description. So task node, string description. And we want to make sure that we initialize some things. We want task description variable to be whatever the user puts, so description. And we want next to be pointing to null pointer. We don't want anything dangling. We don't want any pointers that don't point to anything. We want to make sure that we keep track of all of our pointers. So that's what this is going to be doing. And then something important here. I'm going to create the to-do list destructor here. Destructor. There we go. Okay. So when the main function ends in our main.cpp, which we will create, any local objects inside main, including the myList object that we're going to create, that will go out of scope. And when an object goes out of scope, its destructor is automatically called. And we do things like this to prevent memory leaks and problems like that. So we want to deallocate memory and then terminate the program. So we're going to say to-do list and then tilde for a destructor, to-do list. And we're going to output cout destructor. I don't know why I can't spell destructor today. Destructor called, exclamation point, deleting all tasks. And this is just something extra. It's not in the requirements documentation. It's just something I'm putting because I want you guys to know that this is getting called, right? Otherwise it's like, did it get called or not? We use outputs in a way that alerts us to what is and isn't working in the code, and getting a visual for what's going on really helps with the learning process, I think. So we'll include that there. And then task node pointer current equals head. Okay. So task node asterisk current equals head. Here, the pointer current is going to be initialized to point to the head of the list. The head is the first node of the linked list. And by setting current equal to head, we are setting up to start the cleanup process from the first node in the list. Okay, so that's how that works. And then we need to do this again. And then I'll explain these after I finish typing them. So this line, next node is a temporary pointer that's going to be used to hold the next node in the list while we delete the current node. And this is important because when we delete a node, we lose access to it completely. So we need a way to keep track of the next node to process. And we want to loop through the linked list, right? We don't know how many tasks the person added, so we are going to create a while loop that says current, so while current is not the null pointer. So we want to start the while loop here because current pointer is going to be used to traverse the linked list from the head to the last node. And what we're saying is if current is null pointer, it means we've reached the end of the list. There's no more nodes to delete. So we are going to add next node equals current points to next. This line stores the pointer to the next node in the list. And before we delete the current node, we need to know where the next node is going to be. So if we delete the current node without saving current arrow next, we're going to lose the pointer to the rest of the list. This is going to cause a memory leak if we don't do it. And now we can safely delete current. So this is the command that we're going to use to free this from memory. And after this line, the current node is going to be no longer valid and its memory is going to be reclaimed by the system. So after we've successfully done this, we can say current equals next node. And this updates the current to point to the next node in the list, which we previously saved in next node. So now current points to the next node, and the loop will repeat for that node, deleting it and moving on to the next node until all the nodes have been deleted. And that concludes the destructor. So let's go ahead and save up to this point. Make sure that you are saving as you are programming, so that you don't end up with, I don't know if your computer, I don't know, it's good practice. All right, so let's go ahead and create the add task function for the to-do list class. So I'm going to scroll down a little bit so we can keep it on frame. And the first thing I want to say is add a task to the list. And it's a void function, doesn't return anything, of the to-do list class, scope resolution operator, add task, const, string, task description. All right, that looks good. So the first thing we want to do is to create a new node. And task node, don't worry, I'll go over why I'm doing this in a moment. Task equals new task node, task description, end of statement. So this is the code we are writing to create a new task node, right? So a new node is created dynamically using the new keyword, and this thing right here, new task, this line calls the constructor of the task node class, which takes a string as an argument, and the task description is passed to this constructor and will be assigned to the task description field of the new node. This pointer to new task now points to the newly allocated memory, which contains a task node that holds the task description and a null pointer for its next for its next pointer, right? We have that here. We defined it here, so that's what should be happening. Okay, and after that, we can create a conditional statement to check, all right, if this is the first node that we're creating, we're going to do this. If it's not, we're going to do something else. So if head is the null pointer, okay, so this is going to check if the linked list is empty. And if it is, this line is going to set the head of the list to point to the new node. So new task, okay, and that should do it. That should be everything. So this is going to make the new task the first node in the list because it's the only one that we have for now. And it's important that we do this because the head pointer needs to always point to the first node in the list. And if the list is empty, the head should point to the newly created one. All right, and then if this is not the case, if we have multiple nodes inside of the task node, we are going to say task node, oops, I spelled it wrong, task node current equals head. So here a pointer that we named current is created and initialized to point to the head of the list. The current pointer will be used to traverse the list to find the last node, or the one where current arrow next is null pointer. Okay, so let's now create a while loop. Current arrow next is not null pointer. Then we're going to do something. This while loop that continues as long as the next pointer of the current node isn't null pointer, we're going to say current equals current next. So while current next is null pointer, right, this looks good. So this line is going to move the current pointer to the next node in the list. And this is how the list is traversed. So we keep moving from one node to the next until this is null pointer. Let me put a space here. Okay. And then after that, I want to say current next is the new task. Finally, after the while loop finishes, the current pointer will be pointing to the last node in the list. And this line makes the next pointer of the last node point to the newly created node, new task, which is effectively adding it to the end of the list. So now, current is the second to last node in the list, and its next pointer now points to the new task node. And that should complete the add a task to the list function. All right, so after that, let's go ahead and create the remove a task by description function. Description. And this is a void function of the to-do list class. Remove task. Let's look at something here. Remove task. Okay. Task. And then this is going to be const string % task description. I don't know why autocomplete isn't taking care of that, but let's go ahead and define it. So the first thing we need to do is we need to set task node current equal to head. So this creates a pointer to current that is initialized to point to the head of the list. The current pointer will be used to traverse through the linked list, checking each node to see if it's matching the description, if its info section matches the description. If that's true, then we're going to remove it. So that's a little preview of what's going to happen. Task node asterisk previous equals null pointer. So this creates a pointer previous and initialize it to null pointer. This node previous will be used to keep track of the node just before current, which is important because when we're removing a node from the list. So initially it's set to null pointer because the first node, like i.e. head, doesn't have a previous node. So next, let's put a little space here. While, let me just check the viewfinder. I want to make sure that you guys are able to see this. Okay, while current is not equal to the null pointer, we're going to do some stuff. Okay, so while current is not null pointer, this while loop runs as long as current is not null pointer, meaning it continues until the end of the list is reached. In each iteration, the function checks the current node to see if it matches the description of the one that we want to remove. So we're going to have a couple of conditional statements here. The first one, if current arrow task description is the one that we're looking for. Okay, so if current, if this if statement checks if the task description in the current node matches the description passed to the function. So whatever the user put, if it matches, that means we found the node that needs to be removed. And then if that happens, then we have another conditional statement. So if that's the case, then we want to say if previous is null pointer. If I spell null pointer right. Put another one of these. So if this if statement checks if the previous is null pointer, which would be the case if the node to remove is the first node. If previous is null pointer, it means that current is pointing to the first node in the list. So if that's the case, if previous, then we can say that if it's the first task in the list, then head is current next. Yeah, so then, so let me just get this straight. So head equals current and next. One second. Okay, so head equals current next. This sets head to point to the next node in the list. Effectively, it removes the first node from the list by making the second node the new head. We do this because if we are removing the first node, we need to update head to point to the next node so that the first node is no longer part of the list. So this is just a special case that we're taking care of in case the first node that we come across matches the description of the one we want to delete. So if previous is head node, I'm just referencing my notes here, else we're going to say previous arrow next equals current next. And this line updates the next pointer of the node before the one being removed to point to the node after current. And this is important because it removes the current node from the list by bypassing it, making previous point to the node that follows current. So if this is the case, that's what. So if this isn't true, then we can do this, and then we jump out of that and we say delete current. So we're going to delete it. If we spell it correctly, we can delete it. And then this deletes the node pointed to by current to free up the memory that was allocated for the node, because after the node is removed from the list, we don't want to leave unused memory behind. So we call delete. This deallocates the memory. So after that, we want to see out. We want to give some sort of feedback to the user, task removed. And we're going to say whatever the task description was, that's what got removed. Again, feedback to the user, and then we return. Okay, so the return exits the function as soon as the task is removed. The reason we do this is to prevent any further unnecessary iterations of code execution. So if a task has been removed, we don't need to continue looking through the list. So we return from the function immediately. Okay, so aside from this, we're going to have a couple of new lines. Previous equals current. And this line updates the previous pointer to point to the current node, which is important because in the next iteration, we need to track the node before current. So before moving current forward, we need to update previous to match current. And then we will say current equals current arrow, I guess, next. And then this moves the current pointer to the next node in the list. This step is important to continue the traversal of the list to find the next task that might match the description. Okay, and then let me just check my braces here and make sure that we're doing good. I think we are. Okay, so then after that, we can jump out and say cout, jump out of the loop and say task. So if this whole thing goes through, and then we say task not found to give feedback to the user, task description, and okay. So if the while loop finishes without finding the task, i.e. current is never null pointer, then this line prints a message indicating that the task was not found in the list. And we go further and we output whatever they put so that maybe they can compare it, right? It's just important to provide feedback to the user, and then we'll save this. All right, so let's go ahead and refer back to our to-do list.h. Looks like we have one more function to define, and then we should be good to go on main.cpp. So we're almost out of the implementation file, and the next thing we need to do is to display all tasks. Okay, so this is a void function. It doesn't return anything of the to-do list class. And again, what was that called again? Display tasks const. Okay, and this is display tasks const. Okay, again, this is going to define the display task function. The const keyword after the function signature, I don't think I talked about that yet, means that this function does not modify any of the member variables of the to-do list class. It just guarantees that the function is not going to change the state of the object. Again, it's only reading the data that's there. So that's what we're doing here. So we're going to start with a conditional statement. If, oh, put an extra space there. If head is null pointer. So we start by checking if head is equal to null pointer. Head is a pointer to the first node of the list, remember. And if head is null pointer, it means the list is empty. There's no tasks to delete. So if this happens, or not delete, output, right? We're not, sorry, we're not a destructor. So your to-do list is empty, exclamation point, to emphasize friendliness, endl, and then return. Return should be appropriate. We should break out of this as soon as this happens. Okay, and then again, I'm just checking my parentheses and keeping track of them. So if this is not the case, so what this is saying is if the list is empty, just tell them and then return. Just prevent further execution of the code. If that's not the case, then we need to task node star current equals head. And we've done this many times before now, but we're going to create a pointer to a pointer called current, and it's going to be, it initializes it to point to the head, the first task in the list, and current is going to be used to traverse the linked list from beginning to end. Okay, so task node current head, cout. Let's create an output here. Your to-do list. We're just going to make it clean and pretty. Again, like the visuals are just for this, the outputs are just for the user, right? They're just feedback, and some of it's just meant to make the output easier to read, easier to understand, follow along with. Okay, we're going to create a while loop to iterate through the task list. Current is not null pointer. So let's see here. This while loop, like the others, is just going to run as long as current is not null pointer. Just continue going for as many of these nodes there are. And we're going to output dash space current, whatever its task description field is. Okay. So this prints the description of the task that current is pointing to, prefixed with a dash, just for readability. Just indicates that it's a task in the to-do list. Current arrow task description just accesses the task description field of the node that current is pointing to. Then after we do this, we want current to now be whatever current next is. And then this moves the current pointer to the next node in the list. The current arrow next is the pointer to the next node in the list. And by assigning current equal to this, basically what we're saying is we're going to continue traversing the list. If this current arrow next. Current arrow next is the null pointer. It means you reach the end. So that's basically it. And that should do it, actually. Let's go ahead and save that. And that should be all the functions that we needed to define. All right, so at this stage of the game, we are going to create the main.cpp file. So let's go ahead and create main.cpp up here, and we'll press enter. And that gives us a blank slate to code onto. And then let me go. I'm gonna close this so that you can have increased visibility here. And then the first thing I want to do with my main file is include some of the IO stream. So by now, I know that you guys probably know this, but it's important for me to say it anyway, just in case there's some of you who aren't sure. This includes the C++ standard library's input-output stream. This is what allows us to use cin and cout for the input and the output. Next, we want to include the string library. And that just allows us to work with strings. We're going to be using a function called getLine, and it's also going to just let us use string variables. And then we will not forget to import todolist.h. So this is going to include the header file where the class todolist and its member functions are defined. This just gives us access to the methods and the other properties that are part of the todolist class. So don't forget to do this as well. And then I'm going to say using namespace. Oh, not that. Autocomplete, not that. This line just makes it so that we don't have to prefix std and then : with standard library functions and objects like cout, cin, string, whatever during the course of the program. So it's just, that's all it does. Int main, and we're going to return 0. We're going to make it return something. So it's just our standard boilerplate stuff. I'm going to save this. Just at this point, make sure that you've saved everything. And then I'm going to go ahead and start. So we want to begin by creating the to-do list object. We're going to call it myList because we're creative. Create the to-do list object. Yeah, it just creates an instant of the to-do list class. We're calling it myList. This object is going to be used to interact with the to-do list, calling its functions like add task, remove task, display task, etc. And then we also need to create a variable, a string variable, to store the task that the user puts. So this is going to create the string to store the user input when they enter a task. Okay, and that went off screen a little bit, but most of these comments are going to be included in the source code that I've included for you as well, just so that you can have them as reference and kind of like help walk you through what's going on. We also need choice, and then this is going to create the number to store the user input choice. Okay. All right. So it's just going to declare a variable choice of type int, store the user choice. Okay. So at this point, we want to create a do-while loop. And a do-while loop is going to be the best option here because we want to display the menu at least once, even if the user doesn't want to choose any of the options. So I don't think we use do-while loops that much in this class, but we're using one here. So create the loop that prompts the user to enter an option, and then use a do-while loop because the prompt needs to happen at least once. Do. Okay. And that's fine for now. I'm really scared about parentheses right now. because we're also going to have a switch statement coming up. But I'll just leave it like this for now. No, I won't. No, I won't. I'm going to actually, no, I can't. Never mind. Okay. Let me go ahead and, okay. So let's go ahead and start by outputting the menu. And we're going to go to a new line, to do list menu. Well, that doesn't need a space, does it? Endl out 1. And the first thing, let's see. So the first one is add a task, the second one is remove a task, third is display the task list, and 4 exits the program. So I'm going to save. The 1, add a task. And those have always been kind of weird for me. 2, remove a task. And then this part, I think you guys got a handle of, just standard output stuff. Tasks. And each of these options are displayed on a new line, which is why we have endl at the end. And then 4 is going to be exit. And then finally, we're going to say enter your choice. Okay. So the lines are just displaying the options that the user can pick, and we're trying to display it in a way that increases readability while promoting simplicity and readability in the code itself. So at this point, we want to take in whatever their choice was. We use cin to do that. Then we're going to use cin.ignore. And this is done to ignore the new line character that's going to be left over in the input buffer. I guess I could talk about that a little bit more. So after after this line, cin choice, the input buffer is still going to contain a new line character, and that's from pressing when the user presses enter to enter in their choice. This line, cin ignore, this is going to ignore the leftover new line character so it doesn't interfere with the future input operation. Like getLine, we're going to use getLine later. And if you kind of want to see how this impacts your code, at the end of this, try running the code without this, and then it kind of results in errors because the loop is going to continue, because it's going to have enter the getLine character as part of the input buffer. It just creates problems. So to prevent that, we use cin.ignore. Okay, and next we're going to say the desired function. So we're gonna be using the switch statement to accept choices, and the desired function of the program most closely matches a switch statement. Okay, so I'm not sure when the last time we used one of these was, so this should be good practice. So we start a switch statement by saying switch, and then the variable choice is what the user inputted, and then a curly brace. So we're going to execute different blocks based on what the choice is. So case 1, so the first case, when it's a 1, this is, oh, you know what? I noticed that it didn't automatically, let me make sure that oh yeah, 1 second, hang on. Okay, it just looks like, I checked and it looks like it doesn't automatically indent, so I'm going to manually indent instead for readability. Enter task description. So the first choice, enter task description, colon space. Ow, my foot's falling asleep. Hang on. Okay. And we're going to use getLine here because we actually don't know how long, how it's going to be more than one character for sure, or more than one string, maybe. So we'll say task, and we're going to say use getLine to get multiple strings. Okay. So we prompt the user to enter a task description. We use getLine to read the full task description from the user, allowing for if the user uses spaces, which they probably will in the task description. Unlike this, this is only going to get a single stream. It's going to stop at the first space. So we're going to use getLine instead. Okay, and then after that, we will say my list.add task. We're going to call the function, and then we are going to put the task on it. Okay, so this calls the add task function from the to-do list class, passing the entered task description as the argument. And then after that, we need to break. And then this is going to end the case 1 block, preventing it from executing any other case. Okay, from here, let me make sure this is matching. Okay, we're going to move on to our second case. And this is going to be removing. So this is going to delete a task from the list. And then we're going to say cout enter task description to remove. Let's see. I think this might be a little too close up. So that's a little better, I hope. Cout enter a task description to remove. We're going to use getLine again. Cin task. And then we're going to use mylist.remove task. We're going to use task as the argument. We're going to break. Okay, so for the second case, just to kind of go over what we did here, prompt the user to enter description, use getLine to get the task description from the user, and then call remove task, the function from the to-do list class, passing the task description to remove it from the list. And then break ends the case 2 block. Now we're going to move on to case 3. And case 3 is displaying all of the nodes in the list so far. So that's pretty easy. We're just going to say mylist.display tasks. No need to put in an argument in this case. And then break. So again, that one's pretty easy. Just call the function, break if that's the one that we picked. And then case 4. This is when we want to terminate the program. We say cout, and then remember we're going to say goodbye with an exclamation point because we're trying to be friendly, and endle, and then break. And remember that with switch statements, we need a default case. And the default for this one is going to be cout invalid choice. Please try again. Okay, and this, let's see, this should work. We're going to, let's see, let me make sure I have enough. Okay, there it is. I was wondering where the next parenthesis was. While, so this whole thing is going to be happening while our choice is not choice 4, basically. And then that looks correct. Oh no, I like the space there actually. Okay. So case 4 ends the program, and then the default is going to print a message that tells the user that their choice was invalid. I think that's good. I'm kind of just reviewing what I have here. I'm going to save at this point. And I think we could try to run it at this point. So just a second. Okay, so I skipped a little bit. I created my launch.json. I'm using Linux, and part of the requirements for running um, the code on Visual Studio Code is that I have a launch.json. But I also need to compile this program, and I do that manually through the terminal. So let me see if I could get this on screen for you so you can check this out. This is going to be a little small, but basically what I'm going to do, I don't know if you have the same situation with your computer, but I have to manually go to the folder where this is being stored, and then I have to run something that looks like this, which is going to compile the code together and create an executable that I will call to-do list. So I guess I don't really want to take up too much of your time, so I'll skip that step, and then I'm going to shoot right on over to the execution of the code. Okay, I'm going to run the code now, run without debugging, and here it is. I'm going to increase the view, and then I'm going to probably increase it one more time. Okay, so my first entry will be a number 1, add a task, wash dishes. My second will be to add another task. It's going to be to clean the room. And then another one, we're going to do the laundry. Okay, everything's working so far. Let's go ahead and remove a task. And we're going to say do the laundry is the one we removed. That works fine. And then let's display the task. Wash dishes, clean room. That looks good. We can exit by pressing 4. Goodbye, destructor call, deleting all tasks. Perfect. This code is not without issues. And I will say that if you play with it a little bit, if you enter some invalid choices, it might cause problems. However, the way that if you want to add more to it, you can. This is simply a demonstration so that you get used to using linked lists and classes too, but mostly linked lists because that's the current topic for this week. So I'm going to go ahead and end the video here. As always, I am here to answer questions, and happy coding, and yeah, have a wonderful day.